Hello friends, I am Dr. Shailesh Kaushal, Department of Management, Faculty of Management Studies, University of Lucknow, Lucknow. Today I am going to discuss the topic correlation. Now we will discuss the two topics, that is the methods of studying correlation, Pearson coefficient correlation and Spearman rank correlation coefficient. In previous lecture, we have discussed about the scatter diagram. So in a Pearson coefficient of correlation, both the variables should be metric data. Metric means the data should be normally distributed, and as well as the data should be interval or ratio scale data. Is it clear? So in a Karl Pearson coefficient, we can denote by r, small r, and its value will vary -1 to +1, means we may get r value between -1 to +1. If it is in this range, -0.3, -0.6, if it is in this range, the r value -0.3, so it is low degree of negative correlation. Here moderate, if r value -0., so it's a -0.6 to -0.3, it is moderate. And if it is above 0.7 and below -1, it is high degree of negative correlation. Same as if value below the 0.3, low degree of positive correlation. If it is between +0.3 and +0.6, it is moderate. And if it is above 0.5, it is high degree of positive correlation between the two variables. So basically R will tell us whether the value the positive or negative. Degree of correlation is expressed by a value of coefficient, and the direction of change is indicated by negative or positive. Positive means same direction, negative means opposite direction. The formula of the Karl Pearson coefficient of correlation R equal to summation xy upon square root summation x square into summation y square. When division is taking, then the formula it is modified, that is summation dx dy. Dx basically x I minus x bar. Is it clear? And then n means total number of variables. When we have the two variables value x and y, then we can calculate the value of r. The third column we can create dx. Dx means x I minus x bar. Dy means y minus y bar. And then we will multiply dx dy, and then the dx square and this. So if we want to calculate manually, then first of all we will write the observations in a first column x, second column y, dx nothing but xi minus x bar, dy nothing but yi minus y bar, dx dy dx square dy square. So you can write all the observations and then manually you can calculate these value and put in this formula, then we will get the value of, but we will do it through SPSS software. So in a calculate the mean of the two value, first of all we will take in the first column, we will take through first column, it is x bar, add all the observations x1 plus x2 and so on and divided by number of observations, and then we find the value of y bar, calculate deviation. Deviation means dx equal to xi xi minus x bar, same as division of y, and then we will put all these value in this formula and then we will get the answer. Now the interpretation, how to interpret the results. The value of correlation coefficient R ranges from -1 to +1. I already told you many times. So R will lies only -1 to +1 range. The range is fixed. R value always between the -1 and +1. If R equal to +1, it means the correlation between the two variables is perfect positive correlation. If R equal to -1, then the correlation between the two variables is said to be perfect, and perfect negative correlation between the two variables. If R equal to 0, it means there is no correlation between the two variables. The properties of correlation coefficient. The value will lies -1 to 1. The correlation coefficient is independent of the change of the origin and scale. And then coefficient of correlation is the geometric mean of two regression coefficient. It means the bxy, it is regression coefficient, and this is also regression coefficient. When we multiply both and take the square root, then we will get the coefficient, the R, coefficient correlation. The one regression coefficient is positive and other coefficient is also, so there is a positive correlation. If one is negative and another is, then the negative correlation. Assumptions of the Pearson correlation coefficient. The first of all, we should check there should be linear relationship between the two variables. When the two variables are plotted on a scatter diagram, there should be a straight line will formed by the point. It may be positive, it may be negative, but there should be a straight line. There should not be non-linear relationship. Always there should be a straight line between the two variables. Cause and effect relation exists between different forces operating on the item of the two variable series. Now, advantage of Pearson's Pearson coefficient of correlation. It summarizes in one value the degree of correlation and direction of correlation also. It means it may be +-1, range may be +-1. So degree means strength. If its value near to 1, it is positively highly related. Its value minus, then the high degree of negative correlation. Direction means sign. So if sign is positive, positive correlation. If it is negative sign, there is a inverse or opposite direction. limitations of the Pearson coefficient. One is always assume there should be linear relationship between the two variables. Interpreting the value of R is difficult because sometimes when you multiply yx and dxy, so R will be plus and minus. So how will you judge? Because R will get two values. So then you will check the relationship between x and y. If both are positive, then there is a positive correlation. If one is positive and another is negative, then there is an inverse relationship. The value of correlation coefficient is affected by the extreme values, and this is time consuming methods also. If you manually you perform, then you need to create very long table. Already I have discussed about this table. This is your table. It is x, y, dx, dy, dx square, dy square, dx, dy, and then you take the x bar, add all observations and divide by summation x upon n, same as y bar, summation y upon n, and then you uh, create the third column xi minus x bar. So it is very time consuming when you perform through manually. Find the value of correlation. Time consuming method. But in SPSS, it is 1 minute you can. Now, the next term is the coefficient of correlation. Coefficient of determination. Coefficient of determination basically R square. R square tell us about the variance. How much variance through one independent or other independent variables. The convenient way of interpreting the value of the correlation coefficient is used to use of square of the coefficient of correlation, which is called the coefficient of correlation. For example, in a multiple regression analysis, beta 0, x1, beta 2, x2, and so on. If both the independent variable influencing significantly y and r square value is 40%. What does it mean? This is your explained part and this one is unexplained part. It means 60% unexplained part. It means we did not include other independent variable which can influence this dependent variable. So R square basically tell us ki how much these variables influencing or contributing to the dependent variable. Suppose R equal to 0.9. So R square equal to point. When you square of this value, we will get the R square. This is coefficient of determination. This would mean that 81% of the variation in the dependent variable has been explained by the independent variable. It means 19% unexplained part. We took those variable who can influence 81%. If we add more variable, then the R square value will increase. R square value increase. The maximum value or the coefficient of determination, the maximum value of R square equal to 1, because if it may be positive correlation, negative correlation, and it may be positive correlation. If R is perfectly 1 and R is equal to perfectly negative 1, then R square value, when you R square minus 1 square means plus 1. So it's a maximum value. 1, and R square value will varies from 0 to +1. Negative नहीं होगा, there is no negative. So R square is 1 because it is possible to explain all of the variance in Y, but it is not possible to explain more than all of it. So coefficient of determination basically explain variation and total variation. For example, in a multiple regression equation, when you uh, take two variables, this is your unexplained part. So, for example, this 60%, this is explained part, and 40% unexplained part. So, R square, how will you calculate? Explained upon the 100. So, this is your total variation 100, and then the R square value 60%. This is 60%, or R square equal to 0.6. 0.6. You can convert into percentage also. So this is the formula of find the coefficient of determination explained part. Or suppose the R equal to 0.6, R equal to 0.3. It does not mean that the first correlation is twice as strong as the second, because R can be understood by computing the value of R square, not the value of R. So here R square is 0.36 and R square is second case 0.09. So it is not twice. This implies that the first case 35% of the total variation is explained, whereas in second only 9% of the total variance is explained. So this R value will not tell us about the twice or thrice value. If R equal to 0.9 and R equal to 0.3, no. R square will tell us. Then Spearman correlation coefficient. When our data in a rank, so we use Spearman rank correlation coefficient. When a statistical series in which variable under study are not capable of quantitative measurement, for example, in a beauty contest, so it's a qualitative, but can be arranged in a serial order. In such situations, Pearson correlation coefficient cannot be used. In such case, Spearman rank correlation, because here data is ordinal, not interval or ratio scale. Here for Spearman rank correlation coefficient, we use ordinal data, because we give rank to the respondents or participants, like in a beauty contest or in an interview. So interviewer basically give the rank, the first rank, second rank, third rank, and so on. So here this is our formula. So through formula we can create or estimate the rank correlation coefficient, and the D difference, and N means total number of observations. So there may be two types of problem you can see here. The first one is the rank given, and another is rank is not given. Now here interpretation of rank correlation coefficient. The value of rank correlation coefficient range again from -1 to +1, same as the Carl Pearson coefficient of correlation, and R equal to 1, then there is a complete agreement in the order of the ranks, and the ranks in the same direction. If it is positive, R equal to -1, there is a complete agreement in the order of the rank, and ranks are in opposite direction. And R equal to 0 means there is no correlation between the two. Then rank. So I told you there are two types of problem. One is when actual rank are given, and second case when actual rank are not given. So manually you can calculate. So there are rank. This is your R1, R2, and this is difference. Okay. So manually, for example, the numbers of students, maths and science. So these are the numbers, ranks. Okay. Then you difference in the third column R1 minus R2, and then square, and then put value in the formula, and then you will get the value of R. And second case may be problems where the ranks are not given. If ranks are not given, then we need to assign ranks to the data series. The lowest value in the series can be assigned rank 1, or the highest value in the series can be assigned rank 1. We need to follow the same scheme of ranking to the other series, then calculate the rank correlation coefficient in similar way as we do when the ranks are given. And then we will put all the values in the formula. Merits. What are the merits of the Spearman correlation, rank correlation? This method is simpler to understand and easier to apply compared to Pearson correlation method. Another advantage, this method is useful where we can give the ranks and not the actual data, because it is qualitative term. In a beauty contest, we give rank 1, 2, 3. So we have option, we can give rank 1 to 10 if 10 participants are there. So you can give the rank. This method is used where the initial data in the form of ranks. Limitations cannot be used for finding out correlation in group frequency distribution. This method should be applied where n exceed equal to 30. And advantage of the correlation studies, show the amount of relationship present, can be used to make predictions about the variable under study, can be used in many places including natural setting, libraries, etc. Easier to collect correlational relationship data. Now I'm taking the my case studies of this. So here we have four variables. One is revision time in this case study. The other is exam performance, and then tension, exam tension, and gender. Gender means male and female. So I'm taking this case study for applying the Pearson correlation coefficient. Yes, now you can see this case study. Coding 1 and 1 for male and 0 means female. So here there are four variable, three variable continuous variable, and fourth is the categorical variable. So here we want to find out the relationship between the two. Revision time, the first variable, that is revision time, and exam performance. So exam performance and revision time. So we know that more revision, more performance, good performance. So there is a positive correlation. Another relationship, if we see here, the y and x, exam performance and exam tension. So there is a negative relationship. Because more exam tension, your performance low. Less exam tension, your performance high. So here there are two types of data. One is positive correlation and another is negative correlation. Now how to calculate it? So go to analyze, then correlation, and here bivariate. Analyze, correlation, and bivariate. Now I am selecting, first of all, I want to check revision time, correlation between revision time and exam performance. So here I am selecting only two variables, the revision time and exam performance. Is it clear? So revision time and exam performance, by default it is Pearson correlation coefficient. So you can, there is no need to tick, but if this is by default, tick Pearson coefficient and then OK. When you do OK, we will get the output, and output, this is my output. So we can see the output. In this output, exam performance, the revision time and exam performance. Revision time and exam performance, there is a positive correlation, low degree of correlation, because R value equal to plus 0.36, and here it is P value less than 0.05. So it is significant also, significant. So there is a positive, uh, low degree positive correlation between the revision time and exam performance. So here we can develop our hypothesis also, null and alternate hypothesis. The null hypothesis, there is no relationship between revision time and exam performance. But in an alternate hypothesis, there is a significant relationship between revision time and exam performance. So we can test our hypothesis also here. Now we see the other relationship. There are the relationship between the two variables. Two variables here, two variables. The one variable exam performance and another exam tension. Here we want to know whether the relationship between exam performance and tension positive or negative. So how will we do it? Analyze, then correlation, bivariate, reset, revision time. I'm taking exam performance and exam tension, and then by default it is tick Pearson, and then OK. After OK, now we can see our result. So there is negative relationship, R value minus 0.450. So there is a negative relationship between the two. So there is a negative relationship. So we can draw the graph also between the two. One variable, that is exam performance, another exam tension. So here we can say there is a negative or inverse relationship between the two variables. Now we can see here the if we can draw the graph also through a scatter diagram, we can understand the nature of the relationship between the two variables. So here scattered plot, double click, simple bar. So revision time and exam performance. So there should be positive correlation. So you just check through scatter diagram. Yes, there is a positive correlation. And then there is a, you can see the relationship between the two is positively related to each other. Now you can check the another relationship, whether the exam performance and exam tension uh, negatively related or positively, although through formula we found there is a inverse relationship, but through graph also we can understand. So here I'm taking exam tension and dragging and dropping here, and then okay, and after okay you can double click and then add reference line from this equation. So exam performance and exam tension. So सॉरी ये गलत लाइन हो गया. डबल क्लिक, now we take the other relationship between gender also. So analyze, then correlation, bivariate, then means exclude, for gender we can see we can divide our data split file on the basis of gender. Now the relationship may be slightly different for both the cases. So I am performing again. Split file, analyze, then correlate, bivariate. My file has been split. Now you can see there are two results, one for male and another for female. So through this, the female, the R value equal to minus 3.96, and for male the R equal to minus 0.509. It means men are more the performance, bad performance comparison to the female, because R value uh, less for female. Next is the Spearman correlation coefficient. Another example. This is the point by serial correlation. So correlation next, you can go through this book. It is very good. The partial correlation. So go through this ND field book. It is very nice. So I am taking the partial correlation. Yes, partial correlation. In a partial correlation, now you can see the partial correlation. In a partial correlation, analyze, then correlate, partial, correlate, and then partial. So here we can take all the three variables simultaneously. Sorry, the revision time and exam tension controlling, and then okay, yes, this is my output. Revision time and exam tension. So exam performance, revision time and 0.103 is partial correlation. Now I take the partial correlation. Partial correlation, go to analyze, correlate, partial, exam tension, and then options, zero order correlation. You are controlling the third variable, and then okay, now you can get this result. So the revision time and exam performance, the value 0.366. So there is a positive correlation between the two, the positive, okay. And then exam tension and exam revision time, there is a negative. So it is simple correlation, but when you control the variable, that is exam tension, then the relationship, revision time, that is positive, and exam performance and exam tension, it, that is the 0.103. But when you do not include this, you do not add the exam tension and you are taking only three variable, then the relationship is different. So you can see revision time and exam performance are equal to 0.103. So this is partial correlation. And then revision time and exam performance are equal to 0.366. When you are adding all variable, then the R value is different. When you controlling the variable exam tension, then R value will decrease. So this is your partial correlation. So this is about the partial correlation, and one is the uh, Kendall tau or Spearman correlation. Spearman and correlation, yes. Now you can see the another case study. The creativity and rank. So in this case, the creativity 40 and rank is 4 and rank is 1. So this data of 50 respondents data. So here there are rank. In this case, the 10 tests, 5 respondent in each group. So the one group, the rank is 1 and the creativity skill 48. The rank, second rank holder means more rank, creativity less. So there is an inverse relationship. Here rank 1 means more intelligent and creativity more. So when your score tie, then you can use the Kendall tau also. So analyze your here the one data in a the one data that is in a ordinal and another data that is interval or ratio scale data. So when your one variable data is discrete and another is continuous, then we can use the Kendall tau and Spearman correlation. So here I am using first of all Spearman correlation and then I will perform Kendall taus. So select both the variables and then okay. So results we can see here, results we can see. So there is a negative relationship, creativity and rank in competition, because rank 1 means good and rank 5th means the poor. So here there is a negative relationship. When you, if your data ties, then you can perform Kendall tau. So here the analyze bivariate correlation, bivariate, tick this button Kendall tau and then okay. Now the relationship, negative relationship, but the degree change. Here the R value 0.673 and here R value minus 0.804. So Spearman correlation coefficient. So we should use the Kendall tau method when one variable is continuous and other variable ordinal. So this is about the small introduction of the correlation. So thank you very much.